is singly even order magic squares. Okay. Okay, let's look at what is a singly even order magic square. A singly or a single even order magic square is one whose order is divisible by 2 but not divisible by 4. Okay, so this order is 6. 6 is divisible by 2. That means it is an even number. Okay, it is an even number, but it is not divisible by 4. So 6 by 6 is known as the singly even order magic square. How about 10 by 10? Is this double or singly?
Singly.
Yes, because you can divide it by 2. That means it's an even order magic square, but it's not a doubly even order magic square. So it's 14 by 14. Okay, and so on. So let's look at this 6 by 6 magic square and see how we are going to fill this in first. Okay. Okay. Okay, if we want to fill in so our number, if you're filling in as a normal magic square, so the numbers will start from 1, 2 up till
36.
36. Yes. So what is the magic constant here? What is our magic constant? What is n?
6.
6. Yes. 6 square plus 1 over 2. This is 36, 37. 37 times 6 over 2.
117.
1.
Yes, 111. So the sum for each column and row and diagonal will be 111. Okay, to fill this magic square, first we are going to divide this into four boxes, 4 big squares. Okay, so this is 1 square, 2, 3, 4. Okay, and we are going to name this A, B, C, D. Okay, A along the diagonal, A, B, C, D. Okay, so this is how we are going to start filling the magic square. Okay. Okay, so we have 4 sections here. If you notice, the 4 sections are, the order for each section here is 3 by 3, right? Each section here is 3 by 3. So we will build a magic square with numbers 1 to 9 in section A. And then in section B, we will continue with 10 and finish with 18. Section C is 19 to 27. Section D is 28 to 36, correct? Section A is 1 till 9. Section C will be 10 till 18. Section B, yeah? Section B will be 10 to 18. Section C will be 19 till 27. And section D will be 28 to 36. So far, okay? So you see this is a 3 by 3, which means this small square here, these 4 squares here, they are odd magic squares. In odd magic squares, we can fill using the Siamese method, correct? Okay.
Yeah.
So, which means we can fill in very fast using the Siamese method. Just going to put it. Okay. So let's fill in 1 to 9 in the first sun. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? This is this one. Okay. Now let's fill in this B. B, we are going to fill in 10 till 18. So we start in the center here. This is 10. Okay, so this is 10. 10, this will be 11. 12 cannot go down. 13, 14, 15, 15. So 16, 17, 18. Correct? And then C will be 19 to 27. So this is 19. So C is 19 to 27. 19, 20, 21 cannot. So 22, 23, 24, 25, 26, 27. Okay. And then D will be, D is 28 to 36. So this is 28, 29, 29, 30, 31, 32, 33, 34, 35, 36. Now you add each column. Okay, now can you add and tell me how much is of each column or each row? Is it 111? Is it 111? Yes? No?
Yeah.
Is it? Just try one row. Is it 111? The first row here. Does it give you 111? How much do you get the first row? Anyone? How much is 15 plus 26 plus 19 plus 24? 84. Correct? This total is 84. So it is not equals to 100 and we want 111. So that means we haven't finished yet. Okay. So you look at these 6 squares that we have to do something about this. Okay. 1, 2. Okay. These 3 squares and these 3 squares. Okay. You see there are 6 squares here. Okay. That we have highlighted in red or blue. Okay. So the red numbers have to be moved where the blue numbers are and vice versa. So the blue numbers we're going to move to where the red numbers are, and the red numbers we are going to move to where the blue numbers are. Okay. So before we do that, okay, now we're going to move the numbers. So we're going to take 8, these 3 numbers we're going to move. Okay. So 8, 5 and 4, we're going to bring it down. 8, 5 and 4. We're going to bring it down here. 35, 32, 31, take it up. 35, 32, 31. Okay, now it's done. Now it's a 6 by 6 magic square where all the totals will give you 111. You can check it out first, okay? Okay? So this is how we fill a 6 by 6 magic square. Any questions? So in your RMK, they want you to know about 4 times 4, 4 by 4, 6 by 6, and 8 by 8. Okay, these 3 you need to know, and you also need to know odd magic squares n by n times n, which where n is an odd number. So 3 times 3 or 5 times 5 or 7 times 7. Okay, 7 by 7. So you need to know how to fill this magic squares. So before you fill the magic squares, find the magic constant first, fill in the numbers using any of the methods you have learned today, and then make sure you check every single row, column, and diagonal. Okay, so we are finished with singly even order magic squares. Okay, so okay, the last thing that we're going to do today is operations on magic squares. Okay, say you have a magic square here. We're going to do operations. Operations on magic squares. Okay, say you have 1, 2, 3, 4. Sorry. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, say you have a magic square like this. Okay, what happens when you add or subtract or multiply each entry in the magic square? Okay, let's see here. Okay, if we add, say we want to add 5. If we add every single number with 5, what do we get? 8 plus 5? 8 plus 5? No, you're there not. Or if you're left, 8 plus 5 is 13. So 1 plus 5?
6.
6. This? 11. 3 plus 5, 8. 5 plus 5, 10. 7 plus 5, 12. 4 plus 5, 9. 9 plus 5?
14.
14. 2 plus 5, 7. So is this also a magic square? The second one here. Number 2 here. Square number 2. Is this also a magic square? Can you add the, how much is all, what is the sum of all the entries in the first row? 13 plus 9, 10, 20, 30. Yeah? Yes, it's 30. This row, 10, 20, 30. Okay, how about this column? 10, 20, 30. Diagonal, also 10, 20, 30. So this is still a magic square. So we can do operations on magic squares. We can add, subtract, multiply, and divide. We still get a magic square. Okay, one more example. Okay, one more example. Say, from the first magic square, we want to multiply by 4. Okay, we want to multiply by 4. And we want to add, then we want to add then add 5. Okay, in other words, we can say, supposing this entry is represented by x, so we can also say we want to do 4x plus 5. Correct? This is the operation that we want to do. 4x plus 5. We want to multiply by 4, then add by 5. So 8 times 4, 32. 32 plus 5, 37. 1 times 4, 4. 4 plus 5, 9. 6 times 4, 24 plus 5, 29. 3 times 4, 12 plus 5, 17. 5 times 4, 20 plus 5, 25. 7 times 4, 28 plus 5, 33. Okay? 4 times 4, 16 plus 5, 21. 9 times 4 is 36 plus 5 is 41. 2 times 4, 8 plus 5, 13. Now let's check, is this a magic square? 37, 30, 40, 50, 60, 68, 75. Okay, we have 75. The diagonal, 20, 30, 40, 50, 60, 75 also. Okay, the row 40, 50, 60, 75. So this is also a magic square. So we can convert magic. So magic squares can be used in class for teaching. Okay. So when you want to teach like addition or subtraction or multiplication or division, instead of always giving the students standard operation like this, standard algorithm, this is called a standard algorithm. Okay. Instead of always asking them to do standard algorithm, once in a while we can give them something different like this. Okay. You give them a magic square, ask them to do the different types of operations, and then they can check the answers. Okay. So this is the purpose of doing operations on magic squares. Okay. Okay. Any questions so far?